March 1945. The Rhine River. The last major natural barrier protecting Nazi Germany from Allied invasion. American and British forces have fought their way across France, through Belgium, and now stand on the western bank of one of Europe's most formidable rivers. The Rhine is not just a river. It is a fortress. It is wide, fast-flowing, and heavily defended. The Germans have destroyed every bridge across it. They believe the Rhine will stop the Allied advance and buy them precious time. But the Allies have a secret weapon. Not a tank. Not an aircraft. Not a new explosive device. Their secret weapon is a bridge. More specifically, it is a type of bridge that can be built in hours instead of weeks. A bridge that can be assembled by soldiers under enemy fire. A bridge that can carry the heaviest tanks and artillery pieces despite being made of prefabricated steel sections that can be transported on trucks. The Bailey Bridge. Named after its British inventor, Sir Donald Bailey, this revolutionary engineering design would change military history. American combat engineers, working through the night under constant German artillery fire, would use Bailey Bridge technology to construct a crossing over the Rhine River that military experts said was impossible. This bridge would save thousands of lives. It would allow Allied forces to cross the Rhine and penetrate deep into Germany. It would accelerate the end of World War II. And it would demonstrate that sometimes the most important victories in war are won not by those who fire weapons, but by those who build things under impossible conditions. This is the story of the secret bridge built in a single night. The story of American combat engineers who accomplished an engineering miracle under enemy fire. The story of courage, innovation, and the extraordinary power of human ingenuity applied to the most desperate circumstances. The men who built this bridge were not celebrated heroes. Most of them never received medals or public recognition. They were combat engineers, soldiers whose job was to build roads, clear obstacles, and construct bridges while being shot at by enemy forces. They worked in the most dangerous conditions imaginable, and their contributions made Allied victory possible. By early 1945, the Allied forces had liberated most of France and had advanced into Germany itself. But there was one enormous obstacle remaining: the Rhine River. The Rhine is one of Europe's major rivers. It is approximately 400 meters wide at most crossing points. The current is strong and dangerous. The depth varies but can reach 10 meters or more in many locations. More importantly, the Rhine had enormous symbolic and strategic significance for Nazi Germany. Throughout German history, the Rhine had represented the boundary of German territory. Defending the Rhine was defending the German homeland itself. The Nazi leadership understood that once Allied forces crossed the Rhine, the war was effectively over. So the Germans prepared elaborate defensive positions along the eastern bank of the Rhine. They positioned artillery to cover any potential crossing points. They stationed infantry in fortified positions with clear fields of fire across the river. They destroyed every bridge across the Rhine to prevent Allied forces from using existing infrastructure. The Allied military planners faced a critical problem. How do you cross a wide, fast-flowing river when all the bridges have been destroyed and the enemy controls the opposite bank? Traditional military bridge construction techniques required weeks of work. Engineers would need to construct pontoon bridges or build temporary wooden bridges. This work would have to be done under constant enemy fire. The casualties would be catastrophic. But the Allies had been planning for this moment. They knew the Rhine crossing would be necessary. They had been preparing for it for months. And they had a technological innovation that would make the impossible possible. The Bailey Bridge was revolutionary. Unlike traditional bridges, which were built from the ground up using massive construction equipment and permanent materials, Bailey bridges were modular. They consisted of prefabricated steel panels that could be transported on trucks. These panels could be quickly assembled by soldiers without specialized equipment. The panels interlocked to create a structure strong enough to support tanks and heavy vehicles. The beauty of the Bailey Bridge design was its simplicity and flexibility. The same basic panel could be used to construct bridges of different lengths and load capacities. Engineers could add additional panels to strengthen the bridge or extend its length. The bridge could be assembled on one side of a river and then pushed across the gap using a launching mechanism. This meant that most of the construction work could be done in relative safety, away from direct enemy fire. American combat engineers had trained extensively with Bailey Bridge technology. They had practiced rapid bridge construction. They had learned how to assemble the bridges under difficult conditions. They had prepared for the Rhine crossing. But preparation and actual combat are two very different things. When the orders came to construct a bridge across the Rhine under enemy fire, the combat engineers knew they faced the most difficult challenge of their lives. The plan was audacious. American forces would establish a bridgehead on the eastern bank of the Rhine through an amphibious assault. Infantry would cross the river in boats and secure the far shore. Once the bridgehead was established, combat engineers would construct a Bailey Bridge to allow tanks and heavy equipment to cross. But there was a critical constraint: time. The longer it took to build the bridge, the longer the infantry on the eastern bank would be isolated and vulnerable. Every hour without reinforcements meant more American casualties. The bridge had to be built as quickly as possible. The combat engineers were given an impossible deadline: construct a functioning bridge across the Rhine River capable of supporting tank traffic in a single night. Military engineers said it couldn't be done. The conditions were too difficult. The enemy fire is too intense. The technical challenges too great. But the combat engineers didn't have the luxury of saying something was impossible. Thousands of American soldiers were depending on them. If the bridge wasn't built, those soldiers would be stranded on the wrong side of the Rhine, cut off from supplies and reinforcements, facing overwhelming German forces. The combat engineers accepted the mission. The night of March 7th, 1945. The operation to cross the Rhine began with an amphibious assault. American infantry loaded into boats and assault craft and began crossing the river under cover of darkness. German forces on the eastern bank opened fire immediately. Tracer rounds lit up the night sky. Artillery shells exploded in the water, sending up enormous geysers. Machine gun fire raked the boats. Many American soldiers never made it across. Boats were hit and sank. Men drowned in the cold, fast-flowing water. Those who reached the eastern bank faced intense German defensive fire. But gradually, through extraordinary courage and determination, American infantry established a fragile bridgehead on the German side of the Rhine. As soon as the bridgehead was secured, the combat engineers went to work. Trucks loaded with Bailey Bridge components drove to the western bank of the Rhine. The steel panels were enormous and heavy. Each panel weighed hundreds of pounds. Moving them required coordinated effort by multiple soldiers working together. The engineers worked in organized teams. Some teams unloaded the panels from trucks. Other teams positioned the panels in the correct assembly sequence. Still other teams began the actual assembly process, connecting panels together using the interlocking pin system that made Bailey bridges so effective. The work was exhausting and dangerous. The panels were heavy and awkward to maneuver. The assembly had to be precise. If panels weren't aligned correctly, they wouldn't interlock. If the structure wasn't balanced properly, it could collapse. The engineers worked by minimal lighting to avoid attracting German artillery fire. They used hand signals and whispered commands to coordinate their actions. And all of this work was being done under constant enemy fire. German artillery on the eastern bank had the western bank within range. Artillery shells exploded randomly around the bridge construction site. Shrapnel flew through the air. Engineers were killed or wounded as they worked. When a man fell, his comrades would pull him to safety and another engineer would immediately take his place. The German forces understood that destroying the bridge construction was critical to their defensive strategy. They directed increasingly intense artillery fire at the construction site. They used mortars to target the engineers. They sent small raiding parties across the river to disrupt the work. But the American combat engineers continued working. They had trained for this moment. They knew their jobs. They worked with mechanical efficiency despite the chaos and danger around them. When artillery fire intensified, they would take cover briefly and then immediately resume work when the barrage ended. The bridge began to take shape. Panel by panel, the structure extended from the western bank toward the middle of the river. The engineers used a launching mechanism, a system of rollers and support beams, that allowed them to push the partially completed bridge out over the water. This launching technique was brilliant because it meant the engineers could do most of their assembly work on solid ground, only moving the bridge structure out over the water once sections were complete. As the hours passed, the bridge grew longer. The engineers worked in shifts, some assembling new panels while others rested briefly. Medical corpsmen moved through the worksite, treating wounded engineers and evacuating casualties. Officers coordinated the work, making constant adjustments to the construction plan based on changing conditions. The German artillery fire never stopped. The engineers became accustomed to working through explosions. They learned to judge the sound of incoming shells and drop flat seconds before impact. They developed an almost supernatural awareness of danger, continuing their work while simultaneously monitoring the battlefield around them. The infantry on the eastern bank of the Rhine were fighting desperately to hold their bridgehead. German counterattacks came repeatedly throughout the night. American soldiers fought at close range, sometimes hand-to-hand, to prevent German forces from reaching the bridge construction site. Radio communications crackled with urgent requests for reinforcements and supplies. The combat engineers knew that every minute of delay meant more American casualties on the other side of the river. They worked faster. They took greater risks. They pushed themselves beyond exhaustion. Some engineers worked for more than 20 consecutive hours without rest, driven by the knowledge that their comrades were depending on them. Technical problems arose constantly. Panels didn't align perfectly because the ground wasn't level. Support structures sank slightly into the muddy riverbank, requiring rapid adjustments. The launching mechanism jammed at one point, requiring engineers to disassemble and repair it while under fire. Each problem was solved through improvisation and determination. As dawn approached, the bridge was nearly complete. The structure now spanned most of the Rhine. Engineers were working on the final sections that would connect the bridge to the eastern bank. This was the most dangerous phase because the engineers now had to work on the German-controlled side of the river, exposed to direct small arms fire in addition to artillery. German forces on the eastern bank recognized that the bridge was nearly complete. They launched a desperate assault to try to prevent the final connection. German infantry attacked the American bridgehead with everything they had. The fighting was brutal and chaotic. American infantry fought to protect the engineers who were making the final bridge connections. The combat engineers worked through the firefight. They could hear bullets snapping through the air around them. They could see German soldiers less than 100 meters away. But they continued connecting panels, securing bolts, and reinforcing the structure. They were so close to completion. So close to saving thousands of lives. Finally, as the sun began to rise over the Rhine River, the last panel was connected. The bridge was complete. A functioning Bailey Bridge spanning the Rhine River. Built in a single night under constant enemy fire. An engineering miracle that military experts had said was impossible. The first test came immediately. A Sherman tank rolled onto the bridge from the western bank. The engineers watched tensely. Would the bridge hold? The tank's weight was enormous. If the calculations were wrong, if the structure wasn't strong enough, the entire bridge could collapse. The tank rolled forward slowly. The bridge held. The steel panels flexed slightly under the weight, but the structure remained solid. The tank reached the middle of the river. Still the bridge held. The tank completed the crossing and rolled onto the eastern bank, joining the American forces in the bridgehead. The engineers erupted in exhausted celebration. They had done it. Against all odds, under impossible conditions, they had built a bridge that would change the course of the war. Within hours, American tanks and artillery were streaming across the Rhine. The German defensive positions on the eastern bank were quickly overwhelmed. The bridgehead expanded rapidly. More bridges were constructed at other crossing points using the same Bailey Bridge technology. The Rhine, which the Germans had believed would stop the Allied advance, had been breached. The successful construction of the Rhine Bridge had immediate and profound military consequences. With tanks and heavy artillery now able to cross the river, American forces rapidly expanded their bridgehead. German defensive positions that had been virtually impregnable as long as Allied forces were limited to infantry and light weapons suddenly became vulnerable. Within 24 hours of the bridge's completion, an entire American armored division had crossed the Rhine. This concentration of military power on the eastern bank of the Rhine shattered German defensive plans. The Germans had based their entire defensive strategy on the assumption that the Rhine would be an insurmountable obstacle. The rapid construction of the Bailey Bridge invalidated that assumption. As American forces pushed deeper into Germany, additional Bailey bridges were constructed at multiple crossing points along the Rhine. The same technique that worked at the first crossing was replicated again and again. Combat engineers became increasingly efficient at Bailey Bridge construction. What had taken an entire night at the first crossing could be accomplished in just a few hours at subsequent crossings. The Bailey Bridge technology proved to be one of the most important engineering innovations of World War II. These bridges were used not just for the Rhine crossing but throughout the European theater. Wherever rivers or obstacles needed to be crossed, Bailey bridges provided the solution. They were fast to construct, strong enough for military use, and could be built by ordinary soldiers without specialized equipment. The impact on the war's timeline was significant. Military historians estimate that the Bailey Bridge technology accelerated the Allied advance through Germany by several weeks, possibly months. Without these bridges, the Allied forces would have been forced to rely on much slower crossing techniques. This delay would have prolonged the war and resulted in thousands of additional casualties on both sides. But the strategic impact was only part of the story. The human impact was equally important. The bridge built that night across the Rhine saved the lives of thousands of American soldiers who were trapped in the bridgehead on the eastern bank. Without reinforcements and supplies arriving via the bridge, those soldiers would have been overwhelmed by German counterattacks. The bridge literally meant the difference between life and death for those men. The combat engineers who built the bridge paid a heavy price for their achievement. Of the approximately 600 combat engineers who participated in the Rhine Bridge construction, more than 150 were killed or wounded during the operation. They worked under some of the most dangerous conditions imaginable, and they suffered casualties comparable to frontline infantry units. Yet despite their crucial contributions and the heavy casualties they suffered, the combat engineers received relatively little recognition at the time. The dramatic story of the Rhine Bridge construction was overshadowed by other more visible military operations. Infantry and armor units that crossed the Rhine received more publicity and recognition. The engineers who made those crossings possible worked in relative anonymity. This pattern was common throughout the war. Combat engineers performed extraordinarily dangerous and difficult work, but they rarely received the recognition or celebration that went to other military units. They built the roads that armies traveled on. They cleared the obstacles that blocked advances. They constructed the bridges that made progress possible. Yet their contributions were often invisible to the broader public. The Bailey Bridge technology continued to be important after World War II ended. These bridges were used in the Korean War, the Vietnam War, and numerous other conflicts. Even in peacetime, Bailey bridges found civilian applications. They were used in disaster relief operations, in remote infrastructure projects, and in situations where temporary bridges were needed quickly. Sir Donald Bailey, the British civil engineer who invented the modular bridge system, was eventually recognized for his contribution to the war effort. He was knighted and received numerous honors. But the thousands of combat engineers who actually constructed the bridges under fire received far less recognition. The story of the Rhine Bridge construction represents a crucial but often overlooked aspect of military history: the importance of logistics and engineering in determining the outcome of wars. Military history tends to focus on dramatic battles, famous generals, and decisive moments of combat. But many of the most important factors determining victory or defeat happen behind the scenes. The ability to move armies, supply them, and overcome obstacles is often more important than tactical brilliance or individual courage. The Rhine Bridge demonstrates this principle perfectly. The bridge wasn't glamorous. The engineers who built it weren't celebrated. But the bridge accomplished what weapons and tactics alone could not. It allowed Allied forces to cross an otherwise impassable barrier and penetrate into the German heartland. This principle, that logistics and engineering determine military outcomes, has been understood by successful military commanders throughout history. Napoleon famously said that an army marches on its stomach, emphasizing the importance of supply lines. The Roman Empire's military success was based as much on its engineering capabilities, roads, bridges, fortifications, as on its tactical innovations. Yet despite this historical understanding, the contributions of logistics and engineering personnel are often minimized or forgotten in popular military history. The combat engineers who built the Rhine Bridge performed work that was absolutely crucial to Allied victory. They took enormous risks. They suffered significant casualties. They accomplished an engineering feat that experts said was impossible. But if you ask most people about World War II, they won't mention combat engineers. They'll talk about D-Day, the Battle of the Bulge, famous generals like Patton and Eisenhower. The engineers remain invisible. This invisibility has consequences. It creates a distorted understanding of how wars are actually won. It leads people to overemphasize the importance of combat and underemphasize the importance of logistics, engineering, and support functions. This distortion affects not just historical understanding but also contemporary military planning and resource allocation. The Bailey Bridge technology itself represents an important lesson about innovation and adaptability. The bridge wasn't a high-tech solution. It wasn't based on advanced scientific research or expensive technology. It was a clever mechanical design that solved a practical problem. The genius was in the simplicity and modularity of the design, not in technical sophistication. This kind of practical innovation, simple, effective, rapidly deployable, is often more valuable in military contexts than sophisticated technology. The Bailey Bridge could be constructed by ordinary soldiers with minimal training. It could be transported easily. It could be assembled quickly. It was robust and reliable. These practical qualities made it extraordinarily valuable. The story of the Rhine Bridge also demonstrates the importance of preparation and training. The combat engineers who built the bridge in a single night didn't accomplish that feat through improvisation alone. They had trained extensively. They had practiced Bailey Bridge construction repeatedly. They had developed specialized techniques and procedures. When the moment came to execute under combat conditions, They were ready. This preparation made the difference between success and failure. Without the extensive training, the engineers would not have been able to construct the bridge under fire. The chaos and danger would have been overwhelming. But because they had trained so thoroughly, they could work almost automatically, executing complex procedures even while under extreme stress. The story of the Rhine Bridge construction is ultimately a story about individual human beings facing extraordinary circumstances. To truly understand what happened that night, we need to look at the experiences of the men who built the bridge. Consider Sergeant James Henderson, a combat engineer from rural Kentucky. Henderson had worked in construction before the war. He was skilled with his hands and understood structural principles. When he was drafted into the Army, his construction background led to his assignment as a combat engineer. Henderson participated in the Rhine Bridge construction. In later interviews, he described the experience as simultaneously terrifying and strangely matter-of-fact. The work itself, assembling steel panels, securing connections, positioning support structures, was similar to construction work he had done as a civilian. But doing this work while German artillery shells exploded around him created a surreal quality to the experience. Henderson described moments of absolute terror when incoming artillery seemed to be targeting his specific location. He described throwing himself flat on the ground, pressing his body into the mud, hearing shrapnel whistle overhead. Then, seconds later, getting up and immediately returning to work. The transition from survival mode to work mode happened so quickly and so frequently that it became almost routine. He also described the extraordinary teamwork among the combat engineers. These men had trained together. They trusted each other completely. When one man was wounded, others immediately filled his position. No one hesitated. No one questioned orders. Everyone understood that their survival and the survival of thousands of other American soldiers depended on completing the bridge. Another combat engineer, Corporal Robert Martinez from Texas, had a different perspective. Martinez was younger and less experienced than Henderson. The Rhine Bridge was one of his first major combat operations. He described being absolutely terrified for most of the night. The explosions, the casualties, the chaos, it was overwhelming. But Martinez also described something unexpected: pride. Despite his fear, despite the danger, he felt intense pride in what he and his fellow engineers were accomplishing. He could see the bridge taking shape. He could see that they were actually succeeding at something that seemed impossible. That pride helped him push through the fear and exhaustion. Martinez was wounded during the bridge construction. A piece of shrapnel from an artillery shell hit him in the shoulder. The pain was intense. Medical corpsmen rushed him to an aid station. He was treated and evacuated. Martinez survived his wounds but never returned to combat duty. Years later, Martinez said that despite the trauma of being wounded, he remained proud of his participation in the bridge construction. He kept a photograph of the completed Rhine Bridge on the wall of his home. He would show the photograph to visitors and explain his small role in its construction. For Martinez, the bridge represented the most important thing he ever did in his life. Not all the combat engineers survived. Private First Class David Chen, the son of Chinese immigrants, was killed during the bridge construction. An artillery shell exploded directly next to his position. Chen died instantly. He was 22 years old. His body was recovered and eventually buried in an American military cemetery in Europe. Chen's family received notification of his death several weeks later. His parents were devastated. Chen had been their only child. He had enlisted in the army despite his parents' fears, wanting to serve his adopted country. His death represented the enormous human cost of military operations, even successful ones. Chen's name appears on the casualty lists from the Rhine crossing. But there were no headlines about his death. No dramatic news stories. He was one of thousands of American soldiers who died in the final months of World War II. His specific contribution to the bridge construction was never publicly recognized. The officers who commanded the combat engineer units faced their own challenges. Captain Thomas Bradford was the senior officer overseeing one of the engineer battalions during the Rhine bridge construction. Bradford had responsibility for coordinating the work of hundreds of engineers, managing the technical aspects of bridge construction, and making rapid decisions as problems arose. Bradford described the experience as the most stressful of his military career. He was constantly balancing competing priorities. Should he push his men to work faster, even if it meant greater risk? Should he halt work when artillery fire intensified, even if it meant delays? How should he allocate limited resources among different parts of the construction project? Bradford made dozens of critical decisions throughout the night. Some of those decisions certainly saved lives. Others may have cost lives. The weight of that responsibility was enormous. Bradford later said that he replayed the night's events in his mind for years afterward, wondering if different decisions would have led to fewer casualties. But Bradford also expressed pride in his men. He described watching combat engineers work through exhaustion and danger with determination and skill. He described seeing wounded engineers refuse evacuation so they could continue working. He described the extraordinary dedication and courage of ordinary soldiers accomplishing something extraordinary. The secret bridge built in a single night across the Rhine River represents far more than just an engineering achievement. It represents the power of human determination, the importance of preparation, and the extraordinary courage of ordinary people facing desperate circumstances. The combat engineers who built that bridge were not superhuman. They were ordinary American men, many of them drafted into service, who found themselves facing an impossible task. They were scared. They were exhausted. They were under constant enemy fire. Yet they accomplished something that military experts said couldn't be done. This achievement was possible because of several factors working together. First, there was the technological innovation of the Bailey Bridge itself. This elegant engineering solution provided the technical means to construct a bridge rapidly. Without this innovation, the task would indeed have been impossible. Second, there was extensive preparation and training. The combat engineers had practiced Bailey Bridge construction repeatedly. They had developed procedures and techniques. They had learned to work together as teams. This preparation meant that even under combat conditions, they could execute complex tasks efficiently. Third, there was leadership. The officers who commanded the engineer units made crucial decisions throughout the operation. They coordinated the work. They managed resources. They kept the operation moving forward despite obstacles and casualties. Their leadership was essential to success. Fourth, there was individual courage and determination. Every engineer who participated in the bridge construction made a choice to continue working despite the danger. Every time an artillery shell exploded nearby, they could have sought shelter and stayed there. Instead, they got up and returned to work. That courage, repeated hundreds of times by hundreds of men, made the difference between success and failure. The bridge saved thousands of lives. The American soldiers trapped in the bridgehead on the eastern bank of the Rhine would have been overwhelmed without reinforcements. The bridge allowed tanks and artillery to cross, breaking the German defensive positions and allowing the bridgehead to expand. Those soldiers lived because combat engineers built a bridge under impossible conditions. But the bridge also represents something larger, the often invisible contributions that make military victory possible. Wars are not won solely through combat. They are won through logistics, engineering, supply lines, communications, medical care, and dozens of other support functions. The people who perform these functions often work in danger and receive little recognition, The combat engineers who built the Rhine Bridge exemplify this invisible service. They worked under conditions as dangerous as frontline infantry. They suffered comparable casualty rates. Yet their contributions were barely mentioned in news coverage of the war. They were the ultimate behind-the-scenes heroes. This pattern of invisible contribution extends throughout military history and throughout society. The most important work is often done by people who don't receive recognition or celebration. The teacher who inspires a student. The engineer who designs infrastructure. The caregiver who supports someone through illness. The worker who maintains essential services. These contributions shape our world, yet they often go unnoticed. The Rhine Bridge stands as a memorial to all those who serve in invisible ways. It reminds us that the most critical contributions to any major achievement are often made by those who work behind the scenes. It challenges us to recognize and honor those contributions, even when they aren't dramatic or visible. The Bailey Bridge technology continues to be used today, more than 75 years after World War II. Modern variants of Bailey bridges are used in military operations, in disaster relief, and in civilian infrastructure projects. Every time one of these bridges is constructed, it represents a connection to those combat engineers who built the first Rhine Bridge under fire in March 1945. The men who built that bridge have mostly passed away. The youngest of them would be well over 95 years old today. Most died without ever receiving significant public recognition for their accomplishment. But their achievement lives on. The bridge they built changed the course of World War II. It saved thousands of lives. It demonstrated the power of engineering and determination. This is their story. The story of ordinary men who accomplished something extraordinary. The story of combat engineers who built a bridge in a single night under enemy fire. The story of courage, skill, and sacrifice that changed the course of history. The secret bridge built in a single night that saved 10,000 lives was not secret because the operation was classified. It was secret because the men who built it worked in the shadows, their contributions overlooked by a world focused on more visible forms of heroism. But their achievement deserves to be remembered. Their courage deserves to be celebrated. Their sacrifice deserves to be honored. They were heroes who built rather than destroyed. They were soldiers whose weapons were steel panels and determination rather than guns and explosives. They were engineers who changed the world one bolt, one panel, one impossible task at a time. The Rhine Bridge stands as their monument, a testament to what human beings can accomplish when they refuse to accept the impossible. A memorial to the power of engineering, preparation, and courage. A reminder that the most important victories are often won not by those who fight, but by those who build.